Okay, our last video was an introduction of mixed numbers. Now we'll try to add and subtract mixed. Alright, so let's try some exercises. Okay, I guess I have that plus in there that I have not added animation to, so just ignore that for now. So we have one figure, one hexagon here that's fully shaded, so that is regarded as 1. And we have a second one, and we have a second one. Alright, and we have a fourth one. Alright, so these 3 spinning wheels or spinning hexagons, that's 3. And we can add this one here, which is divided into 6 with 5 parts shaded, so therefore that's 5, 6. So when you add this, it's just, as I mentioned from the last video, you just add the whole number and the fraction by just putting them together. Right, so this one here, you have 2. Okay, so that's 2. And if you add that to the other one, which is 1/4, alright, so we add this. So therefore, this is equal this is just equal to 2 and 1/4. Alright, so adding mixed numbers is not really that bad. It's, in fact, so 3 stars, and you want to add this, and that is 3 parts over 5. So that's 5. The star is divided into 5 parts, so that 5 will be your denominator and 3 is your numerator. Okay, so that is 3 and 3/5. Alright, so now from this video on, this is a little bit of introduction for how to subtract a fraction from a whole number. Alright, so let's review a little bit about fractions. So let's consider this one whole purple circle or cylinder. Okay, so this is one whole. Is it divided into any parts? No, it's not divided into any parts. So this is 1/1. And the same pie was divided into 2 parts. So this is still the same size, one whole. And it's divided into 2 parts since both parts are shaded. So that's 2/2. So as you can see, both circles are equal, only that the second part was divided into 2 parts. So if you look closely, the first one is 1/1, the second one is 2/2. Okay, alright, so let's consider the third figure. This is the same, exactly the same circle that we have in the first and second, only that it was divided into 3 parts. And since all parts are shaded, so that's still one whole, we call that one, this fraction as 3/3. It's divided into 3 parts, that's why you have the denominator 3, and all parts are shaded, that's why you have the numerator 3. Okay, so the fourth circle is divided into 4 parts, but still one whole because all parts are shaded, so that is 4/4. So if you look closely at all the circles, they're all equal because they're all one whole, and but just shaded differently. Okay, so any fraction with the same numerator and denominator is equal to 1. So therefore, if you have like 100/100 or 250/250, that's still equal to 1. Okay, so let's try some more problems here. Let's try this star. Okay, so this is one whole star, and we would like to subtract this star. Okay, so this star is one whole because the whole star is shaded, and the second star is divided into 5 parts, but only 3 parts are shaded, so that is 3/5. And as you can see, this is a whole number, and this one, okay, it sort of got crazy over there. Okay, that is a fraction. So we're subtracting a whole number as a fraction from a whole number. Okay, so from the previous page, we know that 1 can be equal to a fraction as well, as long as the denominator and numerator are the same. So what fraction would we use for 1 to make it equivalent, an equivalent fraction to 1, so that it will be easy to subtract 3/5 from? Okay, So as you can see, since the second fraction 3/5 had a denominator of 5, you will need also a denominator of 5 for the whole number to make it easier. Remember, when you subtract fraction, they have to have the same denominator. Okay, so 5/5, that is equal to 1, isn't that right? Because the numerator and denominator are the same, so that is equal to 1. Okay, so therefore 1 is equivalent to 5/5. Okay, we subtract 3/5. Okay, now we can subtract this because the denominators are the same. So 5 divided by 2, that's 2/5. Okay. Okay, so let's have some more examples. So we have these two circles, and we would like to subtract from that this circle. Right? So that is represented by 2 wholes. You subtract, that one would be 1/3 because it's divided into 3 parts and only one part is shaded. So, okay. Okay, let's go back a little bit. Okay, as you can see, 2 is a whole number and 1/3 is a fraction. So therefore, we need to get an equivalent fraction for 2 so you can subtract it with 1/3, right? So what will that be? So as you can see, I have 6/3 here. How did I get 6/3? Alright, from the fraction that you need to subtract from 2 is 1/3. So therefore, the denominator there is 3. Correct? So therefore, for your 2 to make an equivalent fraction that is compatible with your 1/3, you need to have a fraction denominator of 3 as well. But then you have 2 wholes. So if you can see from the figure above, each part I have divided into 3. So for one whole, you have 3 parts over there, and for the second whole, you have 3 parts over there. So if you count all these parts, you have 6 parts, and each whole is still divided into 3. So therefore, that is 6/3. Is that a little bit complicated? Does it sound complicated? Okay, just remember that when you convert a whole number into a fraction, if the denominator is, say for example in this case 3, you have to make sure that the numerator, when you divide the numerator by the denominator, it will equal to the whole number. If you check here, 6 divided by 3, that is still 2. Right? Because a fraction is like you're dividing the numerator by the denominator. Okay, so another way of finding out what 6 is will be just to multiply your denominator by your whole number. In this case, 3 times 2, the denominator, 3 times 2, that's 6. Okay, so that's a much easier way to find it. Alright, so minus 1/3. So as you can see now, we have the same denominator, therefore we can subtract that. Okay, alright, so that'll be 5/3. Okay, so what is the figure for 5/3? Right, so how does 5/3 look? Okay, so as you know that one whole we have always divided into 3. Okay, so 5/3 would be 5 parts of 1/3, right? So 5 parts of 1/3, we know that one whole has 3 parts of 1/3. So we need 2 parts of 1/3 to add to that. So we have this figure here. So therefore, as you can see from the figure, 5/3 is just equal to 1 and 2/3. How did I get 1 and 2/3 if I don't have to look at the figure? Basically, you just have to divide 5 by 3. So 5 divided by 3, so you have 1 and you have a remainder of 2. So you put 2 with the denominator. So that's why you have. Alright, let's try another one. So you have this pentagon minus this pentagon. Right. So that tethering thing has 3 whole pentagons, and you would like to subtract 4/5 from that. 4/5 because the last pentagon is divided into 5 parts and 4 parts are shaded. Okay, so how do we convert 3 into a fraction with 5 as denominator? Okay, that is the denominator that we want to have. From the previous page, I mentioned that you can just divide your new denominator by the whole number, and that will be your new fraction. Okay, so we have Okay, so we have a denominator of 5, and you multiply 5 by 3. Then 5 is your denominator. You multiply it to the whole number, so you get 15. So therefore 15 over 5 is equal to 3. If you would look at the figure above, every pentagon is divided into 5 parts. Okay, so one pentagon has 5, the second pentagon also has 5, the third pentagon also have 5, so that is 15 parts. Alright, over 5. Over 5 because each pentagon is divided in 5 parts. Okay, so we'd like to subtract that by 4/5. So now we have the same denominator. So that's like 15 minus 4. So we have 11 over 5. So how does that look? 11 over 5, okay, would be like these two pentagon of 5 parts each, and one more part from the third figure. So how many 1/5 do we have? We have 11/5 there. Or in other words, that is 2 wholes and 1/5. Okay. So let's try some more examples. If you can find, I think you have some exercises in the book, and it'll be much easier if you practice some more of this. Okay.